Just remind ourselves of the fundamental principle of counting, which we met in junior cycle. So if we were to toss a coin and throw a dice, the coin yields 2 outcomes, and the trial that is throwing the dice yields 6. So 2 by 6 gives us 12 possible outcomes, thanks to the fundamental principle of counting. If we have a menu with 2 starters, 3 mains, and 4 desserts, then we have 2 by 3 by 4 possible outcomes or meals. Okay. So let's look at an example here. A code consists of a letter of the alphabet followed by 2 different digits from 1 to 9. How many codes are possible? Well, we have 26 letters times 9 digits, and then our last digit can't include one of the 9, so times 8 gives us 1872 possible codes. And let's look at arrangements now, or permutations. And the number of arrangements or permutations of n different objects is known as, or can be found, n factorial. So n factorial, or if we use the number 6 factorial, is 6 by 5 by 4 by 3 by 2 by 1. 5 factorial would be 5 by 4 by 3 by 2 by 1, and so on. And it's on your calculator. If you want to find 6 factorial, you type in 6, shift, and the x minus 1 key, and that will calculate for you 6 by 5 by 4 by 3 by 2 by 1. Okay, and you know we just remind ourselves the number of arrangements of n different objects is equal to how many objects we have factorial. Okay, so here's an example here now. The letters of the word Tuesday are arranged in a line. How many different arrangements are possible? There's 7 letters, n is 7, so we look for n factorial arrangements. 5,040 different ways we can rearrange the 7 letters. Okay. Now, we might be asked how many of these arrangements begin with T and end with the vowel. Okay. Well, to find that, we have to say, okay, we have T at the beginning, okay, and we have a choice of 3 vowels in our arrangements, and that leaves us with 1, 2, 3, 4, 5 letters to play around with in between the T at the beginning and one of 3 vowels at the end. So the solution is to find 5 factorial, multiply it by the 1 arrangement here, and by the 3 different arrangements for each of the vowels there, and that gives us 360 possible arrangements of the letters in Tuesday with T at the beginning and ending in a vowel. Another example, how many ways can the letters of the word numbers be arranged? There's 7 letters, so n is 7, look for n factorial, 7 factorial, 5,040 different ways we can arrange numbers. In how many ways are the letters M and B always together in the arrangements? Okay, so we basically put M and B into one block, and that leaves us 1, 2, 3, 4, 5, 6 different sets to arrange. So that's in 6 factorial ways. But for each of these, M and B can be arranged in 2 ways, i.e. M and B, or this block could look like B, M. So there's 2 factorial ways that can be done. So the total number of arrangements is 2 factorial by 6 factorial, which is 1,440 different ways.